All right, notes 5 is on significant figures. So the reason we use significant figures is we spend a whole lot of time making sure that we read instruments correctly, but then we also need to make sure that any calculations that we do with those numbers reflect how accurate the numbers are. So we need to look at a number and first of all decide how many of the numbers are actually significant. Our rule, or our definition, I guess, is that the digits that are significant is the ones that actually affect or contribute to the accuracy of the measurement. So for example, if my mass was 0.00240 kilograms, and I'm looking at this number, I'm trying to figure out which numbers actually are the accuracy of the measurement, and zeros that are placeholders are not significant. So if I were to take this same object and put it on a different balance, a balance that measures in grams, I would end up with 2.40 grams. So what this is telling me is that I only have 3 digits in here that contribute to the accuracy of the measurement. The leading zeros here, these are what are known as placeholders. So those are not significant. So we need to be able to look at a number and decide how many significant figures it has. The rule we're going to use for that is right dot, left if not. So let's start applying that rule. So right dot, the dot that we are talking about is the decimal point in the number. If there's a decimal point, then we start at the front of the number and we draw an arrow to the right until we hit a digit that is not a 0. That first digit is going to be significant as well as every number to the right of it. Okay. Sorry, I thought this. Okay. So let's look at this first one. So I have a decimal point. So I read the number to the right and I go through all those zeros. And this one has 3 significant figures in it because the 2, the 9, and the 2 are all significant. This one also has a decimal place in it. So I read the number to the right. The first number I run into that's not a 0 is the 1, 2, 3, 9, and 0. So this one has 5 significant figures in it. All right, take a look at that last one and see if you can come up with it on your own. All right, so this one has 4 sig figs because if I draw the arrow in, the 2 is the first number that is significant and then everything else after it as well. All right, moving into left if not. So if there is not a decimal point, then we start at the back of the number and we draw an arrow to the left until I hit a digit that is not a 0. Start underlining there, and then everything else to the left of it is significant. So I start with this number. There's no decimal place, so I read the number, swipe it to the left, and that's significant, that one, so I have 3 sig figs. In my second one, same thing. There's no decimal point, so I'm reading it starting at the back and reading it to the left. Those are my 2 sig figs. And then the last one, same thing. I have 3 sig figs. The last one's pretty easy because there's no zeros. All right, so that is evaluating how many sig figs are in a number. So I'm going to let you practice this. So why don't you pause the video, write these in your notes, and then pick up the video again when you have them. All right, so you'll notice the first 2 are mathematically the same value. And we did that for a reason because when we talk about sig figs, these numbers are very different from each other, and it has everything to do with this decimal point. So this first one only has 2 sig figs in it. The second one has 5. So that 2 sig figs, there's no decimal point, so I read the number to the left. And I have 2 numbers that are contributing to the accuracy of the measurement. But in the bottom one, because I have that decimal point, now I have to read the number starting in the front, reading it to the right. And now I have all 5. All right, so if you look below in your notes, I've got images of, or you may or may not, but I know some of you do, images of different instruments that could take masses. So the one on the left is a triple beam balance. It might not be as accurate. And then the one on the right has 4 decimal places in the number. So the measurements I get from those 2 things are going to be different in accuracy. And that's how we show it with how many decimal places we can put on a number. All right, next one is going to be 3 decimal place here. So I read the number to the right. for 3 sig figs. This one is all 5 because the decimal point says I have to start in the front and read the number to the right. So all 5 of them are significant. This one is 1. This one is 2. All right, and then these last 2. The answers for these, this one is 4 and this one is 3. So this decimal point makes all the difference. So with that decimal point in place, I'm reading the number to the right, and all 4 of them are significant. Without it, I'll read the number 2 from the back and to the left. There's another one in your notes. I believe it is a scientific notation one. I want to say it's like 3.45. And I'm actually going to change the exponent on it to make it a better example. So let's say it's 3.450 times 10 to the 6th. All right, because the negative exponent, it doesn't matter as much. But if I have a value like this, you do not need to rewrite it. Right away, you just assume that everything in the base is significant. So this one has 4 sig figs. If I were to write it out, 3450, and then I added in 6 zeros, and they actually go off the page, then I would read it differently. So this is why if we give you a number in scientific notation, you can assume that everything in the base is significant. All right, so let's deal with calculations. So multiplying and dividing. When you multiply and divide numbers, the answer needs to have the same number of sig figs as the quantity with the least number of sig figs. So in order to do that, I need to look at how many sig figs are in each number, calculate my answer, and then round that answer for the correct number of sig figs, and then I need to figure out the units. So let's jump into an example. So I'm multiplying and dividing, so I know I need sig figs. And it is a good idea to ask yourself that question because we're going to have a different set of rules for adding and subtracting. So since I'm dealing with sig figs, I have to evaluate each one. So this one has 3 sig figs. This one has 4. This one has 3. So then I do my calculation. So plug that into your calculator. Calculator is going to give me 247.49. But this is where I have to evaluate how many numbers I can have in my answer. So again, I have to go with the least number of sig figs. So I need to round this for 3 sig figs. So I need to keep this one, I need to keep this one, and then I need to keep this one, but then I do not need the 0.49, but I have to think about how I'm going to round it. In this case, I would round it, since that's a 4, I would leave the 7 where it is. If it was a 5 or more, I would round it up. So I've got 247 cubic centimeters. The cubic centimeters came from the fact that I took centimeters times centimeters times centimeters. All right, and then now I do this one. So again, I'm dealing with sig figs. So I've got 5 sig figs here. I've got 4 here. So again, I want you to pause the video and go ahead and do that one and then start it up again. So I need to have, the calculator is going to give me 0.392186, but I need 4 sig figs. So I need this one, I need this one, I need this one, and then this is the last one I can have. So I have to look at the very next number to decide what to do. So I've got 0.3922, and then the units, I took grams and divided it by milliliters. So I have to take grams divided by milliliters. All right, continuing on, I had to take a Google Meet call in the middle of there. All right, so adding and subtracting. So adding and subtracting, we have a different rule to follow. So for adding and subtracting, what we do is we now look at the digits after the decimal, or sometimes referred to as the DADS. And we still go with the least number in our answer, but it's not going to be sig figs. It's going to be the digits after the decimal. So we need to determine how many are in each quantity we start with, do our calculation, and then round for that number of the smaller of the two, the number of digits. And then units will be the same as the units we started with. Okay, so take a look at this one. First one, I add these together. So I'm going to deal with dads. And so I'm going to add these to get 132.02 milliliters. But because I have to think about the digits after the decimal, I've got 1 there and I've got 2 there. So I have to go with my least number of digits after the decimal, so I can only have 1. So the correct answer, thinking about how accurate this data can be, is 132.0 milliliters. And I'm sure you're like, wait, what? I just cut off numbers and they're not even useful? Well, yes, but you want to think about the reason why. So here's an example why we do it. So let's say I have a huge graduated cylinder, and I actually do have this one in the lab, that measures 2 liters. And my markings are like this. So my meniscus, let's put my meniscus right in here. And so if you want to look at that and get a little more practice reading scales, you can pause the video, otherwise I'll tell you right away. So if each of these are 20s, I'm between 440 and 460. So it's about 450. Is it 451, 52, 53? I don't know. But it's 450 milliliters. All right, so I have that amount. And then let's say I take another instrument that's super accurate, something that I can read to the tenths, actually, and which means I can read it to the hundredths. So if I take this is 1.23 milliliters. And I add that, I pour that into the 450. So if I just use math, I would say, okay, it's 451.23 milliliters. And the question is, can I claim that that is the volume in my graduated cylinder? And hopefully you're thinking, no, that doesn't make sense because I was unsure about the 450, so I can't just start tacking on more numbers. That's why we use this rule. So my answer can only be as accurate as my least accurate or my least confident number. All right, with that, try the second one. And then again, pause the video and then start up again when you think you have it. All right, so I'm dealing with dads. And this one has 2, this one has 3, so I'm going to need 2 of them. And 124.395 is what the calculator is going to give me. I know I can only have 2 decimal places in my number, so 124.40 would be my answer because this 9 is going to round up based on the 5, and since the 9 rounds up to a 10, that also pushes the 3 up to a 4. And then my unit is grams. All right, try these first 2 on your own and then start the video up again when you are ready to check your answers. All right, so I'm adding on this one, so I have to care about the digits after the decimal. First one, there's 1. Second one, there's 2. I add those, calculator is going to say 644.12 grams. But I can only have 1 digits after the decimal, so my actual answer is 644.1 grams. Second one, I'm dealing with sig figs because this is multiplication or division. I have 4 sig figs here, 3 sig figs there, so when I do that, put it in the calculator, 3.0587, and I can only have 3 sig figs, so I can have this one, and then here's where I need to round. And I have to look at the very next number to see how to round it. So 3.06, and then the units grams per milliliter. So whenever you have that division symbol, you can just combine the units. All right, for the bottom one, the way you do mixed operations is you follow your same rules of what you do first. So I'm going to add first, but I need to apply the rule at the end of that addition before I move on to the division. So I would apply the rule, so I add those together, and I need 2 digits after the decimal because they each have 2. So I get 4.91, and I'm going to stay consistent with my units. Again, it's always good to track the units through, so 4.91 meters. And then divide that by 9.7 seconds. So now that I'm dividing, now I have to think about a different rule. Now I have to think about sig figs. So I've got 2 sig figs here, 3 sig figs there. Calculator is going to give me 0.506, but I have to round it for 2 sig figs. So my answer is going to be 0.51 meters per second. All right, hopefully that's good. Let me know. We'll have what we're doing in class tomorrow is we'll do a low stakes quiz, prepping you for the assessment on Wednesday, which is worksheets 1 through 5. This material will not be on that